For waterproofing relies on wet and dry seals in conjunction with pressure equalization and drainage, which we'll talk about later, about the pressure equalization. Here's a guy putting in a large glazing light. You got a lock strip gasket. This is a dry glazing method. It's faster, less dependent on workmanship, but sometimes, depending on where you are, if you don't have skilled workmen that are what do you call it, certified in the trade, you may want to choose something that doesn't quite need so much skill so that you get a good job. And then there's advanced systems. You can make glass appear seamless, although you can slightly see the vertical joints in there. But this is just butt joint glazing, which is basically the head and the sill, which is the top and the bottom, are what's holding it in there, and then the sides are just pressing together, and there's probably a little caulking in there. So it appears, especially from a distance, that it's just a long, endless ribbon of glass around the building. And that's something you might want architecturally. Here's a mullionless butt joint system seen from the outside. That's what we were kind of just looking at. You can see the joints up close, but if you're far away, it would just look like a solid glass panel. Here you can see this would be an inside or outside glazing system. You got the horizontal strip window. This would be a detail like of the picture we just saw that needs to appear mullionless, meaning you don't want any mullions. Mullions are what hold it in. That's the metal part. The sill and the head are conventionally glazed. You can see on the bottom you have the synthetic rubber glazing gaskets, and that's held in there. And then the vertical joints are just appear seamless, and then at the top you would have another thing like you do at the bottom. So if that's a building that's probably done in that manner, or with very, maybe even all four sides are appear seamless. Everything is completely flush. There's a detail of how they would put it in, steps in assembling a mullion for a four-sided structural exterior finish. So you would, I can't see that as well. You would, you know, it shows the steps here. You would put the glazing on, you would add that clip, you would add a screw, and then you would add your silicone sealant in between the middle of it. Proprietary means that if somebody has it copyrighted, somebody's, you know, whoever made it, that's their system, and you have to give them credit. So that's what they're talking about there. Here's one where you have glass suspended from above with vertical glass stiffeners, and you can, it's hard to see that, but you can, if I touch the screen, it'll move. So. Right there is a vertical, like a column. And that's stiffening this glass so that when the wind comes in from the outside, you know, it won't bow it in. So that's what it's talking about there. And it's a pretty cool looking system. And it's got little, I think it'll show you a better picture in a second. Yeah, there's the little connectors, kind of like little suction plates. It's called a spider fitting that will hold where you put it in, where the four corners meet. There's suspended glazing with a saddle. That glass is actually curved. That looks like an airport. And you can see the cable that it's on that holds it from the top. This is very high-tech, expensive. Anything high-tech like this is going to be super expensive. There you can see that it's attached back to some columns for added support. But the columns are inside, so from the outside it just looks like a floating glass wall. So you can even have glass on your roof, as shown here, and you can see the horizontal, acting like beams. Of course, it needs to be laminated so that it doesn't fall in giant shards and break everything or cut people up. But another thing you have to be careful of is leaking, of course. So all of your joints have to be sealed properly. There's an up close view of that. And then stained glass, which is obviously mainly for looks. I mean, they use it in the church cathedrals and stuff in Europe and even here now, but that's where it began over there. So that's what's, if you're looking up glass in your specifications or you're trying to specify it, it would be in section 8. And then different parts of glass would be in the subsequent sections, but all under 08. You have mirrors, plastic glazing, glazing accessories, meaning the things you use to hang it by, and then any special function glazing. I'll get a video from a I think this is an older one, but it still kind of goes over the making of glass. It's not in HD. Maybe. Are you still thinking? Or did not gonna do it? It worked the other day. Come on.
Maybe you should refresh it.
It's a firm belief.
Good idea.
Corners are meant to be hugged, not cut.
Sound gonna work?
Wood. A product reflective of the times and needs of its makers. A product known as glass. PPG's float glass plant at Meadville, Pennsylvania started its operation in 1968. The plant covers an area of 630,000 square feet, and every day, 7 days a week, produces 1 million square feet of glass. That's enough to equip 20,000 automobiles a day, 365 days a year. As in any glass manufacturing plant, the process starts here, in the batch house. Every day, raw materials are brought into the plant from all over the area by rail and by truck. Offloaded onto a conveyor, which transports them individually to their respective storage silos. The actual batching process begins when each material is transferred from its silo, weighed, and conveyed to the charging end of one of the plant's 2 melting furnaces. A glass melting furnace is a large brick structure, much like an old-fashioned baking oven, where batch materials in cullet, crushed glass, are melted to form liquid glass. Sand, which is by far the major ingredient in glass, normally doesn't melt until its temperature reaches 3,000 degrees Fahrenheit. However, when it's combined with the other ingredients in the batch, sand melts at temperatures below 3,000 degrees Fahrenheit. As the batch materials enter the furnace, preheated air is forced into the chamber by large fans. The preheated air combines with jet streams of natural gas to produce torch-like flames that spew out across the batch, causing it to melt in a matter of minutes. After the batch is completely melted, the fining process begins. This process bubbles that form during the melting process to rise to the surface of the glass and escape into the furnace's atmosphere. Once the fining process is complete, the glass travels into the tank's forming chamber and through an opening called a canal, and into the forming operation known as the bath. This process is based on the fact that liquid glass floats, even as it is hardening on a bath of liquid tin. The spread direction of the glass is controlled by special refractories, which force it to flow downstream toward the other end of the bath. Toothed wheels, called stretch machines, are used to further alter the glass ribbon's thickness and width. Heating elements located above the stretch machines also control the thickness of the glass as it moves along its path into the narrow portion of the bath known as the shoulder. Here, the glass reaches its final width and thickness, ready to be cooled down by a series of water coolers and safely lifted from its tin bath onto the main line's conveyor. When the glass first comes out of the bath and moves into the leer, it has been cooled down to about 1,000 degrees Fahrenheit. The leer's job is to further cool down the glass at a controlled rate in order to ensure that proper stresses are put into the glass to make it cut well. After cooling, the glass comes out of the leer at about 350 degrees Fahrenheit and is further cooled down by large open-air fans at 200 degrees Fahrenheit. As the glass moves through this cooling down area, it becomes more rigid and is carefully inspected prior to the cutting operation. Glass is cut by scoring it with carbide cutting wheels and snapping it over a roller which acts as a fulcrum. Meadville's mainline scoring equipment consists of slit cutters which score the ribbon in the direction of the flow and cross cutters which score it across the flow. After scoring, the glass, still in a continuous ribbon, comes to the mainline snap rolls where the cross cutter scores are open. From here, the plates of glass are rounded down the main line, either one plate at a time or in small groups, to one of several packing lines. Approximately 90% of the glass produced at PPG's Meadville plant is packed at one of several automatic packing lines. The glass is transferred from the mainline conveyors to the automatic packing lines by means of a corner table, a belt conveyor, and roll conveyor all in one. The glass leaves the corner table and enters the snapping conveyors, where the slit cutter scores are opened. After the snap section has been cleared, the glass is conveyed to another corner table, where it's transferred, one row at a time, onto a series of narrow conveyors. Here, an attendant visually inspects each piece of glass for surface or edge flaws, and drops the rejected glass into the plant's cullet system. Next, the glass passes under a machine which drops a special powder on its surface to provide a separation medium between each piece of glass. Finally, the glass is conveyed onto the automatic packer by a VTM system, a vacuum transfer module, which operates like a vacuum cleaner, sucking the individual lights of glass off the mainline conveyor onto the finished stack. As the stack gets higher, an elevator table indexes down to maintain a consistent drop of glass. Once the stack is complete, the elevator table is lowered and the finished container is moved aside, while an empty container is moved under the packing module. Following a final visual inspection for surface and edge defects, the container is sealed and moved off to shipping and out the door to one of many PPG customers. Customers which serve the automotive and architectural glass industries around the world. Customers who buy PPG glass. Dick?
Okay. So now we know, or now we have an idea of how glass is made. So what do we use glass in? We use it in windows and doors primarily. So that's what Chapter 18 is about. And this is important to understand the terminology. You'll use it a lot as architects of what the different parts of the, what they're referring to with the different parts of the door. So the jamb